Welcome to the final linear algebra video of my Machine Learning Foundation series. It's a quick one to leave you with my favorite external linear algebra resources. If you felt that you needed some brushing up on basic algebra, such as rearranging equations, like we did many times so far in this Machine Learning Foundation series, then I recommend checking out the Krohn Academy, which is a website packed with clear explanations of all manner of algebra concepts. You can alternatively check out Khan Academy videos on YouTube or 3 Blue 1 Brown, another YouTube channel that provides amazing videos for basic algebra. In terms of linear algebra, more directly the kinds of concepts that we focused on so far in this Machine Learning Foundation series, I recommend 3 Blue 1 Brown videos again. I also highly recommend checking out Chapter 2 of Ian Goodfellow, Aaron Courville, and Joshua Bengio's book, Deep Learning, which is available free at deeplearningbook.org. The content that we covered so far in this Machine Learning Foundation series was influenced by the content in that chapter. And that might not surprise you because I referenced sections of that chapter a number of times in the Machine Learning Foundation series, namely in situations where I showed you how to do something at a high level in Python, whereas the Deep Learning book provided the underlying math without any corresponding code. You can also check out Chapter 2 of Dyson-Roth et al., their Mathematics for Machine Learning book, and Sheldon Axler's Linear Algebra Done Right is a well-known general linear algebra text in the field without any particular focus on machine learning applications. In terms of what I most highly recommend you study next, well, that would of course be the next steps in the Machine Learning Foundation series. So having now learned foundational linear algebra, we are well prepared to jump into Calculus 1 on limits and derivatives, as well as the Calculus 2 class that will follow on partial derivatives and integrals. Probability and information theory, which is the 5th of 8 subjects in this series, also builds on the linear algebra subjects we've studied already. And finally, the 8th and final subject in the series on optimization ties together all of the preceding subjects, including the linear algebra we've covered so far. Right, so with that, we've reached the end of segment 3 on matrix operations for machine learning. We talked about singular value decomposition, which allowed us to compress an image file. We talked about the Moore-Penrose pseudo-inverse, which allowed us to perform something like matrix inversion of non-square matrices, enabling us to solve for unknowns in systems of equations like those that are common in machine learning. We learned about the trace operator quickly. And then we learned about principal component analysis, which ties together the trace operator and lots of other concepts that we learned earlier in this Machine Learning Foundation series to power PCA, which is a simple machine learning algorithm for handling unlabeled data and finding structure in it. And then just now we talked about my favorite resources for further study of linear algebra. So that's the end of segment 3 on matrix operations for machine learning, which is the final segment of subject 2 in the 8-subject Machine Learning Foundation series. This linear algebra 2 matrix operations subject that we just wrapped up was made up of 3 segments. So we started off with a quick review of essential introductory linear algebra. Then we moved on to decomposition of a square matrix into its eigenvectors and eigenvalues. And only moments ago, we wrapped up the matrix operations for machine learning segment. That means that we're all done with the first 2 subjects of my Machine Learning Foundation series, which also means we've completed all of the linear algebra content of the series. Many aspects of the content we've covered so far, particularly the understanding we've developed of tensors and how to perform operations with them in Python, will serve us well in all of the remaining 6 subjects in the series. The content we covered in this Linear Algebra 2 subject will be particularly beneficial for Calculus 1, Intro to Stats, and Optimization. On that note, up next is Calculus, the study of rates of change, which is essential in machine learning because it allows us to efficiently solve for unknowns, even if we have massive datasets. Calculus, particularly its applications to machine learning, is so elegant and awesome. I can't wait to see you there. To be sure not to miss the next tutorial in this series, subscribe to my channel. Thanks for taking part in the tutorial. I hope you enjoyed it. If you did, please like and comment. To be sure not to miss any of my content, head to johnkrohn.com and sign up for my email newsletter. You're also welcome to add me on LinkedIn. Simply mention that you're a viewer of the Machine Learning Foundation series. You can follow me on Twitter too if that's your social medium of choice. See you next time.